Hello, my name is Eloy, and this is my science fair project. My science fair project is about electricity and paper. So my project is graphite, which conducts electricity and powers light bulbs. My question is, which type of light bulb will work best while powered by a paper circuit? Which means I have four types of light bulbs: LED, halogen, incandescent, and ultradescent. My hypothesis is if I change the light bulb, then it might be brighter because it all depends on the watts and brightness power. And it is true, watts make the light bulb brighter, so I made it to where all the light bulbs are 60 watts. My variables is my independent variable, which are the light bulbs, the light bulbs that I change over each trial. My dependent variable is the power of the light because it depends on how much power the light bulb gets. My constant variables are the alligator clips, the piece of paper, and wires, which I don't change. And my control is how far the light goes in a dark room. My materials are 4 positive and 2 negative alligator clips, 1 9-volt battery, 1 thick piece of paper and or cardboard piece, LED bulb with 3 lights, halogen, incandescent, and ultradescent light bulbs, 60 watts each. And my procedure is attaching the wires to the negative and positive alligator clips. Then you get those and can get the pencil and draw 2-inch long and wide graphite area for 30 minutes and get the first positive and negative alligator clips and connect that to the 9-volt battery. Then the back, because each wire connects 2 alligator clips, so the back of that one, we're going to grab another positive and connect one side to the other end of the one that is connected to the 9-volt battery, and the other end of the one that we just connected to the one that's connected to the 9-volt battery, we're going to connect that one to the graphite area, and we're going to get the other 2 positives that are left, and we're going to get one of the sides and connect it to the graphite area, and get the other side and connect it to the light bulb. And then the negatives, connect one side of the negative goes to the battery and the other side of the negative goes to the light bulb. My results after I conducted all my research is that on trial 1, LED got 2.6 inches, but none of the rest works. Incandescent, halogen, and ultradescent didn't work, which I did research on later on, but I'll talk about that later. So, on trial 2, I got 1.8 inches for the LED, and incandescent, ultradescent, and halogen still didn't work. On trial 3, I got 1.1 inches for LED, and halogen, incandescent, and ultradescent didn't work. For trial 4, I got 0.75 inches, which is less than an inch, and ultradescent still didn't work. So for trial 5, I got 0.25 inches, and it still ultradescent, incandescent, and halogen still didn't work for some reason. And at trial 1, I was confused because none of the lights wanted to work. I saw that they didn't work. I was confused. And I didn't know what to do because I thought I wasn't going to get a good grade because none of the light bulbs work. But once I got to LED, it worked. And I was actually happy that I could actually do something with my experiment. So, none of the house light bulbs wanted to work. Only the LED car light, which I don't think they have any halogen, incandescent, or ultradescent car lights. So I had to change the house light LED to the car light LED because I could either do nothing with my experiment or at least something. So I changed it. In trial 5, I played and I moved the alligator clips, which made it, if you separate the alligator clips even farther, the light gets dimmer. But if you put them as close as possible without touching both of the positive alligator clips, it grows more brighter. So my conclusion is that graphite is made out of free electrons which can move around the air inside the area of graphite, and those electrons carry charges. So anywhere inside the graphite has an electrical charge. And graphite's electrical structure makes it so that the electrical structure, so that the more separated you put the alligator clips, the more dimmer it is going to be. And the more closer you put the alligator clips, the more brighter it's going to be. Also learned while I was playing with more, I squeezed the alligator clips and it actually makes it brighter. So that's another way to make it brighter. While I was doing my experiment, again, none of the house lights worked, but only car lights. And if I could change my experiment, I will only use the LED and measure how far it will go with different amounts of light. And another one, I forgot to put it on there, but another one is that I would measure the light that have the light distance it goes, and I would get the watts depending on the watts. 10 watts for like 20 watts for trial 1, 30 watts for trial 2, 40 watts for trial 3, like that, and I'll see how far it goes, and then the cost of the money, and I'll calculate all that and to see which one is cheaper. Instead of wasting just all this money and all that, I'll just put it cheaper. And then my abstract was that the purpose of the experiment is now that if the cable is too far, we can just use graphite to transport electricity, which is true because in the experiment I found that LED works. I am pretty sure it works for power tools, and it's not really worth anything. It probably like cost $1, but that's not really good until extension cords cost probably like $5, I think, but I'm not sure. And I was trying to research why the house lights didn't want to light up, and I couldn't find anything, but I'm pretty sure it's something about the electrical structure of the electrons. And I wish I could do more with the experiment, but I couldn't find anything that I could do, so I guess we're just gonna have to leave it like that. And when I first saw this project, I didn't know what was gonna happen, but none of them worked except the LED. And I really did meet an objective, which was, it was really fun to conduct, and it was very educational, and I learned a lot more about electricity and electrical structures. And I can actually use graphite for a lot more stuff. That's pretty much the end of my project, so I hope you all liked it. Thank you for taking your time to see my presentation, and I hope you are all having a great day, and may God bless you.